Good day, everybody. Today I would like to repeat a couple of things that we studied on a previous lesson and to start new topic, which will be basis of programming. Let me start with repetition. In the previous sessions, we defined that computer can utilize binary system for alphabetical information and alphanumeric information. For this system, we use ASCII code, American Standard Code for Informational Interchange, and this ASCII code utilized 1 byte per character. 1 byte per character. That's meaning 8-bit, and according to a very famous formula that tell us how many variations we can use for 8-bit, i.e. q number of variations will be equal to in the power of n, where n number of bit, so that will be 2 in the power of 8, so that will be 256 variations. So that is number of symbols, number of characters in English language. That includes capitals, small letters, service symbols, punctuations, and so on. Totally 256 symbols, the entire keyboard. But for internet, when internet actually became popular, for internet we cannot use 256 because this is too small number of symbols. We need to use Cyrillic, we need to use different alphabetical symbols like Ethiopian, Chinese, Japanese, Cyrillic, and so on. And totally it's more than 50,000. So people decided to use different encoding, and different encoding named Unicode, Universal Code, Unicode. Unicode is different from ASCII code and utilized 16-bit per character. 16-bit per character. That meaning 2 byte. 2 bytes per character. And totally that will be according to 2 byte 2 in the power of 16, and that is approximately 65,500. So 65,500 symbols could be encoded in Unicode system. Definitely it includes Chinese, Cantonese, all non-Latin languages like African languages, like Arabic, Hebrew, and so on. From other hand, digital presentation of mathematical numbers like from 0, 1, and so on to 9, which is symbols of decimal system, could be provided also with binary digits. And we can say 0 is 0, 1 is 1, but 2 is 1 0, 3 is 1 1, 4 is 1 0 0, 5 1 0 1, 6 is 1 1 0, 7 is 1 1 1, 8 is 1 0 0 0, 9 is 1 0 0 1. How do I know which number is encoded with such code? It's easy. When I have a binary quantity, let's say like this, and I need to put bin, which is binary, then I easily can convert it to the decimal quantity. So for this I need to put positions, because this is positional numeric system. So that will be 0, 1, 2, 3, and 4. Then we can convert it this way. 1 multiplied by 2 in the power of 4. 2 because we have only 2 digits, 0 and 1. 4 because it is fourth position. 1 because it's number 1. Plus 0 multiplied by 2 in the power of 3, plus 1 by 2 in the power of 2, plus 1 by 2 in the power of 1, plus 0. 0 because multiplier is 0. By the way, any number in the power of 0 is equal 1. So now we can calculate. 2 in the power of 4 is 16. This is 0 because 2 in the power of 3 is 8, but 0 multiplication gives us 0. This is 4 and this is 2. So that is 22 decimal. For decimal system, we have rule for calculation. If I have the highest decimal, which is 9, and I add 1, I will get 10 decimal, with actually named 10. In binary system, we have the same rule, but in binary system, we have highest digit is 1. So 1 plus 1 is equal not 2. 2 is not existing in binary system. That will be 10 in binary. Now, how to prove that arithmetical actions works in binary system? We already know that this number 10110 is equal 22. But what if I add 1 to this, or even 1 1? 1 1 is 3. So let me add it. 1 plus 1 will be 0 and 1 carrying. 1 plus 1 will be 0 and 1 carrying. 1 and 0 is 1 and 1 coming down. Now I need to convert this to decimal. 1 1 0 0 1. How much of this? 0 1 2 3 4 will be 1 by 2 in the power of 4 plus 1 by 2 in the power of 3 plus 0 by 2 in the power of 2 plus 0 multiplied by 2 in the power of 1 plus 1 multiplied by 2 in the power of 0. How to calculate this? That is 16, that is 8, that is 0, that is 0, and that is 1. So that will be 25 decimal. So we took 22, we add 3, 1 1 is equal 3 in decimal, and we get 25. So folks, it means that result of calculation is not dependable on the system which we use when we calculate it. Meaning we can make calculations in binary system. I would like to add a couple of things. You can see here I wrote the values in numbers in decimal and equivalent in binary. How do I know that 6 is 110 or 7 is 111? I just remember that, but I can prove it. Take a look, folks. 6. I said 6 is equal 110. How to prove it? The same way that I did before. I put position numbers 0, 1, and then we'll go for calculations. How much of this? 1 multiplied by 2 in the power of 2. Why 2? Because it's second position, plus 1 multiplied by 2 in the power of 1. That is first position. Then plus 0 multiplied by 2 in the power by 0. So 0 in the power by 0 is 0. 1 multiplied by 2 in the power of 1. 2 in the power of 1 is 2. That will be 2. And that will be 4. 4 plus 2 is equal 6. Decimal. The same way, take a look. 8. I said 8 is 1000 in binary. It's easy to prove. Will be 1 multiplied by 2 in the power of 3. How do I know it's a power of 3? Positions 0, 1, 2, 3. And all others are zeros. Plus 0, plus 0, plus 0. Because these 3 zeros is multiplicators. So that will be 8. Because 2 in the power of 3 is 8. So I can calculate all these numbers. Alright, so I know. Let's make the sample again. Let's take, this is binary 11001. We already know that that is a 25 in decimal. So we will take 11001. Let's add 7 to it. 7 is 111. So we will go 111, and this is binary. Now we can calculate it. According to the rule, rule is here. The highest number plus 1 will be 10. So 1 and 1, 0 writing, 1 carrying. 1 plus 1, that will be 0. 0 writing, 1 carrying. 1 plus 1, 0 writing, 1 carrying. 1 plus 1, 0 writing, 1 carrying. 1 and 1, 0 writing, 1 carrying. Binary. Wow. This is like 1000000. Let's convert it to decimal. 100000. Am I correct? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is binary. Now let's put positions. 0, 1, 2, 3, 4, 5. Will be 1 multiplied by 2 in the power of 5. Plus, and all others are 0. Plus 0, plus 0, plus 0, plus 0, plus 0. That is 5 zeros. 1 multiplied by 2 in the power of 5 is 32, because 2 in the power of 5 is 32. That will be 32. So what we did, we took 25 and we add 7, because 111 is 7. 7. 25 plus 7 is 32. So 32 decimal. Again, folks, that is total proof that I can produce calculations in binary system. That's meaning computer can calculate. And there is no dependability on the system. Computer can work in decimal system, in trinary system, in hexadecimal system, in binary system, and always get the correct result. Alright, now I would like to speak about structure of the computer, which actually gives opportunity to calculate stuff and do arithmetical actions. Definitely, when we calculate it on the paper, we need to have specific paper area where we will put the values which we calculate algebraic formula. For example, I will take a square plus b square is equal c. But this is algebraic. In a matter of calculation of real value, I would like to put a is equal 2 and b is equal 3. What is c? Now what we need to do, we need to substitute 2 in the power of 2 plus 3 in the power of 2 will be 4 plus 9 will be 13. So c is equal 13 decimal after calculation. But how computer doing it? Computer must have a specific device named processor. This processor unit actually doing calculations. So this is electronic device named MP, microprocessor. This microprocessor doesn't have any idea of how to do this, but it's only can do arithmetical actions, plus, minus, multiply, divide, and so on. Without memory, specific memory, how do we have on a white paper, this microprocessor will not be possible to calculate. So we need to have a memory, and that is the same as white paper for us. And definitely microprocessor must have bidirectional connection to memory. Memory structurally is table of data. So that is table, and so we need to enumerate cells. That will be cell number 1, cell number 2, cell number 3, cell number 4, and so on. How big is a memory? Folks, memory is a billion of cells. Billions. Because computer can operate with so multiple of data, so that memory must have big value. But what else we need to put in a memory? In a memory we must have the area where we will put a program. Program is a set of instructions for microprocessor of what to do and how to operate with the data. I said that the program area that you can see here in the memory area is a set of instructions. Definitely, because instructions, they also are coming to memory in a binary form as well as data. So it's a matter of interpretation. How can we understand instructions? What is the bit format of the memory? Sometimes the memory table is 32-bit in one cell, 32-bit. But with the good computers, if you purchase memory, and microprocessor will be tuned to the memory, so they will work with pairs. So the pairing memory and microprocessor could be also 64-bit. So the memory word or memory cell will be much longer in bit and allows you to put more information. Now, interpretation. Data. Data in the memory cell could be in binary form only because the structure of the memory is binary, it's a bits, and definitely byte. 32-bit is 4-byte, 64-bit is 8-byte. Now, how computer understand where is the data and where is the program? Without user and without operating system, which is artificial intelligence, microprocessor cannot detect what is what, because from the side view it's both binary. But interpretation, we can say that beginning from the cell number 100, that will be a program, and beginning from the cell number 1, that will be data. So the memory distribution, it's very interesting job and complicated job, because when we use computer is multitasking device, meaning so simultaneously it can run few programs. Let me give you a sample. You use Microsoft Internet Explorer, simultaneously typing something on the WordPad and simultaneously listening music. So microprocessor works so fast so it can actually do few things simultaneously. But each program could be placed in a separate place, in a separate area in the memory, and feed microprocessor with a set of instructions. Okay, also there is input and output operation. We will call them I/O operations. Input operations when you ask user or you ask somebody to place information in a certain form in a cell. Now, how the program will look like if I would like to recalculate this formula, a square plus b square is equal c. So let's try to make the graphical representation of this program. By the way, graphical representation of the program, graphical form of the program named algorithm. And we can put here this algorithm. So what is algorithm? That is, folks, full representation of the logical features of the program with all actions and all exits and input made in a graphical form. So let's start from the end. We'll go here the word start. Start because computer need to know when to start. Then input output operation. First display text. And text must be in quotation marks, look like this, type A. So when the user typed A, you need to then memorize A. To memorize A, we need to distribute the specific cell for A. Let's distribute cells. I will say cell number 1, cell 1, that will be A, cell 2 will be B, cell B, C, and I will make some cell 4 will be text type A, cell 5 will be text type B. Okay, display text type A. So actually we need to put command display cell 1. This brackets meaning that that will be content of this cell. But in this action I will put not to cell 1, display cell 4 because only in cell 4 this information type A. Write to cell 1. That will be A written to cell 1. Then another thing, display cell 5, and I will put content. display cell 5. After user type the value of B, I will put right to the address 2. Then we will start calculations. Let's take cell 1, multiply by cell 1, and then write cell 1. Then I will put my comment a square now in cell 1. I'll do the same thing with the cell B. Take cell 2, multiply by cell 2, write to cell 2, b square in cell 2. So that is now what I need to do. I need to take cell 1 plus cell 2, write to cell 3, c in cell 3, print cell 3, stop. So my explanation again. Program and other programs, all programs, are allocated in the same memory where data located, but in different areas of the memory, because memory is quite big. Processor does not know how to operate, only can follow the instructions. Instructions is program. Program is a set of instructions. So who actually create the programs? This is a specialty, this profession, named programmers. They know the language of programmers, and they can transmit and translate their program to microprocessor for computers. And let me again to try to explain this formula. A square plus b square equals c. So we will start. Then we need to display text type A. Actually, this text is contents of cell number 4, because we distribute it and we put this textual data for the program. So we need to display cell number 4, not the text, just display cell number 4. When the user input data for cell number 4, for cell number 1, we need to write this data to cell number 1, because what we ask user, type the value of A, and then we'll put it into cell dedicated to A. This is cell number 1. Then display cell number 5. Cell number 5 is a textual constant, a textual information type B. Type B. B meaning the value of B. Actually, a text could be a little better, like type the value of variable B. Then we need to write the value that user indicated to cell number 2. Cell number 2 is a cell dedicated to B. Now we filled up cell number A and cell number B. Now we need to calculate. To calculate A square, we need to take cell 1 and multiply it by cell 1. So that will be what will be inside of microprocessor. That will be A square. Then we need to write what we calculated back to cell A. And then cell 1 is cell A, but now value in cell A will be A square. Then we need to calculate B square. So we need to calculate cell 2, multiply by cell 2, and write the result into cell number 2. I use cell number 2 to save the result B square in cell number 2. Then I need to add cell number 1 and cell number 2. So that will be A square plus B square. And then write the result into cell number 3. C will be in cell 3. Then command is print cell 3 and then stop. Now I need to comment this, that my microprocessor does not understand any words. It can operate with words, but inside of microprocessor there is no understanding what words meaning. Only digits, it, because microprocessors, artificial intelligence, need to understand something. It needs to go to program that make it understand what is what in digital, so in a digital world. So what we need to do, we need to rewrite this program. So let's do this. A square plus B square is C. Instead of algorithm that I used to write in a previous page that I wrote there, I would like to do the same distribution. So I will distribute memory 0001. That cell will be dedicated to A. 0002, cell dedicated to B, but actually that will be cell 0010 because addressation for B will be also in binary. Then cell number 3, 0011, that will be cell number C. Cell number 4, 0100, that is cell number 4, and that will be textual information from the beginning. I'll put it in apostrophe, so that will be input the A value. Cell 5, 0101, that is number 5 in binary, and I will put here input the B value. Now, as soon as operations for the program also could be in digital form, we need to modify the operations with the digital code. Let's go for code of operations. Code of operations. And I will say, let's do this like display. Display will be code of operation 111. Print will be 110. Read will be 100. Write will be 101. Add will be 011. And what else we use? Multiply, that will be 010. Folks, this is digital codes of operations. But operations works with only addresses of the cells because nobody knows any other way to memorize data. So that is my table. So start the program is a business of operating system because it can tell processor that the start area is here, where this program is allocated. I don't know yet because this is operating system business. So let me go for first command that was in the previous display, and display is code. I'll put here. That is code of operation. That is address 1. This is address 2. Address in the memory. So first, code operation 111. What I need to display? Display value A. That will be cell 0100. After my user input the cell, I need to record what seller typed, and that will be write. Code operation is 101, and then I need to put it into A. A is 0, 0, 0, 1. So that is display input A, record A. Then display 111. What we're going to display? Display the text in the cell 0101. 0101, and that will be display input B. Write where? Write code, operation code is 101, and we're supposed to write into B. B is 0010. 0010. Okay, I have A and B. Now I need to multiply. Multiplication is 010. 010. I need to take A, which is 0001, and multiply it by 0001. And then write. Write is 101 to 0001. And I will say A square in 0001 cell. Now, next for B. B multiply B. Multiplication 010. B cell is 0010. Multiply by itself 0010. Write. Write code is 101. Where? To the same cell, 010. B square in 00010. Okay, now we need to add these two. Addition 011, this is code operation. I need to take 0001 and 0010. A square plus B square, and then write it 101 to C. C is the cell 0011, and then print C. Print C. Print is 110 0011. I forgot operation stop. Stop. That will be let's say 001. That will be operation stop. 001. Stop. So let me put comments. B square, that is A square plus B square, put to C. Print C. Stop. So folks, then you can see a real program, how it works. In addition, I would like to say that the computer that we reviewed is hypothetical computer. It doesn't exist in a production or somewhere else. We just designed it ourselves. Take a look. This is just 1, 2, 3, 4, 5, 6, 7 operations. And we put cells in format like you see 4 digital numbers. I'll tell you folks that the real processor is much more complicated. It contains a capability to perform more than several hundreds different operations, and memory addresses also, as usual, more complex than you can see here. But the principles of the modus operandi of this processor, like principle of operation, is the same that we reviewed. Thank you.